Hi there, this is Jan Stoneman. I'm a cloud architect and I'm trying to learn more about AWS right now, and I thought I'd make a video of myself studying. So this might not be the most useful video for other people, but what I'm doing here is reading out loud AWS white papers. Today I'm going to do the AWS WellArchitected Framework white paper from November 2018, and I might comment on the paper as I go, but mainly it's just a way to soak it in a way that works for me, and maybe it'll be useful to some other people. Like maybe you'll be able to consume it while you're washing the dishes or driving, if that's the only time you have to consume AWS white papers. I don't know. Maybe in the end it'll just benefit me, but here goes. So let's see. That's the table of contents. Okay, introduction. Actually, let's read the table of contents. It's interesting to see how this is formatted. Introduction, definitions, on architecture, general design principles, the 5 pillars of the framework, operational excellence, security, reliability, performance efficiency, cost optimization, the review process, conclusion, and then appendix. Okay, so it looks like this white paper is divided up by the 5 pillars of the well-architected framework. Introduction. The AWS well-architected framework helps you understand the pros and cons of decisions you make while building systems on AWS. By using the framework, you will learn architectural best practices for designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. It provides a way for you to consistently measure your architectures against best practices and identify areas for improvement. The process for reviewing an architecture is a constructive conversation about architectural decisions and is not an audit mechanism. That's something I've heard them mention about the AWS well-architected process a lot when I've heard talks about it, that it's not meant to be punitive or a complete one-time audit kind of thing. You can do pieces of it, and you can evolve your architecture over time using it, so you don't have to get it all right at once. So it's interesting that they put it in the very first paragraph. Not an audit, but a constructive conversation about architectural decisions. We believe that having well-architected systems greatly increases the likelihood of business success. AWS solutions architects have years of experience architecting solutions across a wide variety of business verticals and use cases. We have helped design and review thousands of customer architectures on AWS. From this experience, we have identified best practices and core strategies for architecting systems in the cloud. I think what they're trying to say here is this stuff applies to any industry. The AWS WellArchitected Framework documents a set of foundational questions that allow you to understand if a specific architecture aligns well with cloud best practices. The framework provides a consistent approach to evaluating systems against the qualities you expect from modern cloud-based systems and the remediation that would be required to achieve those qualities. As AWS continues to evolve and we continue to learn more from working with our customers, we will continue to refine the definition of well-architected. So I think it's saying here, that you can use these questions that the well-architected framework poses to continually evolve your architecture, and at the same time, AWS is continually evolving this set of questions. This framework is intended for those in technology roles, such as Chief Technology Officers, CTOs, architects, developers, and operation team members. It describes AWS best practices and strategies to use when designing and operating a cloud workload, and provides links to further implementation details and architectural patterns. For more information, see the AWS WellArchitected homepage. So that's just saying who this is for and where you can find more information. Next section, definitions. Every day, experts at AWS assist customers in architecting systems to take advantage of best practices in the cloud. We work with you on making architectural trade-offs as your designs evolve. As you deploy these systems into live environments, we learn how well these systems perform and the consequences of those trade-offs. So it sounds like here they're highlighting that this framework involves trade-offs. For example, do you want to have more durability or more cost efficiency, is what I think they're going to get into. Based on what we have learned, we have created the AWS WellArchitected Framework, which provides a consistent set of best practices for customers and partners to evaluate architectures, and provides a set of questions you can use to evaluate how well an architecture is aligned to AWS best practices. So that's something they've said in the previous section. The AWS WellArchitected Framework is based on 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. So those 5 pillars is how this whole white paper is structured. The pillars of the AWS WellArchitected Framework. Pillar name, operational excellence. Okay, that's just Kindle formatting issues. Okay, here's a description of what they mean by cost optimization. The ability to run and monitor systems to deliver business value and to continually improve supporting processes and procedures. The ability to protect, that's a Kindle formatting issue. So I guess that refers to operational excellence. And then the next one is security. The ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. And then reliability. The ability of systems to recover from infrastructure or service disruptions, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfigurations or transient network issues. And the last one, performance efficiency. Second to last one. The ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. Last one, cost optimization. The ability to run systems to deliver business value at the lowest price point. I wonder why they put that one last. No, I mean AWS is really passionate about making their prices continue to drop year after year. But it does make sense that they list it last, because even from a customer perspective, security matters more than getting the cheapest cost, especially if it's a really important value. And the same goes for reliability and performance efficiency and operational excellence. I think I remember when I was reading this another time that they said, like, or maybe it was in a talk, that operational excellence and security are the non-negotiable pillars, and then you can make trade-offs with the reliability, performance, efficiency, and cost optimization pillars. In the AWS WellArchitected Framework, we use these terms. A component is the code, configuration, and AWS resources that together deliver against a requirement. Wow, that's a very high-level definition. A component is often the unit of technical ownership and is decoupled from other components. Okay. We use the term workload to identify a set of components that together deliver business value. The workload is usually the level of detail that business and technology leaders communicate about. Okay, so leaders are concerned with workloads, which are made up of components, which are the smallest unit of things we're going to be talking about. Milestones mark key changes in your architecture as it evolves throughout the product lifecycle: design, testing, go live, and in production. We think about architectures as being how components work together in a workload. Okay, so sounds like architecture has to do with the interactions between components. I guess that's why you'll typically have a bunch of lines on a cloud architecture diagram. How components communicate and interact is often the focus of architecture diagrams. Oh, yeah, there you go. Within an organization, the technology portfolio is the collection of workloads that are required for the business to operate. When architecting workloads, you make trade-offs between pillars based upon your business context. These business decisions can drive your engineering priorities. You might optimize to reduce cost at the expense of reliability in development environments, or for mission-critical solutions, you might optimize reliability with increased costs. In e-commerce solutions, performance can affect revenue and customer propensity to buy. Security and operational excellence are generally not traded off against the other pillars. That's what I was remembering a page ago, that security and operational excellence are non-negotiable. On architecture, this is the next section on architecture. And for some reason, it is in red font on my Kindle. In on-premises environments, customers often have a central team for technology architecture that acts as an overlay to other product or feature teams to ensure they are following best practice. Technology architecture teams are often composed of a set of roles, such as technical architect, infrastructure, solutions architect, software, data architect, networking architect, and security architect. Often these teams use TOGAF, or the Zachman framework, as part of an enterprise architecture capability. That was interesting. I hear the term solutions architect used for such a wide range of roles, and it's interesting here to see that in this white paper, at least, they make the distinction that a solutions architect deals with software and a technical architect deals with infrastructure. I see it used in other ways, but that's how they use it in this white paper. At AWS, we prefer to distribute capabilities into teams rather than have a centralized team with that capability. There are risks when you choose to distribute decision-making authority, for example, ensuring that teams are meeting internal standards. We mitigate these risks in two ways. First, we have practices that focus on enabling each team we have that capability, and we put in place experts to ensure that teams raise the bar on the standards they need to meet. Second, we implement mechanisms to carry out automated checks to ensure standards are being met. This distributed approach is supported by the Amazon leadership principles and establishes a culture across all roles that works back from the customer. So in that section, they highlighted 3 words: practices, mechanisms, and works back from the customer. It's interesting that they how consistent they are with that message, because I was just watching a reInvent talk about the AWS partner landscape from reInvent 2019, and after the AWS budget CTO or CIO gave a talk, the AWS director of partnerships came on and summarized by saying, "It's great to see how you work back from the customer's needs." And the AWS budget guy didn't use those words, but the AWS guy framed what the talk was about with that kind of AWS language of working back from the customer. So I just thought it was interesting to see it here too. Customer-obsessed teams build products in response to a customer need. There's a very, very Amazon term again, customer-obsessed. For architecture, this means that we expect every team to have the capability to create architectures and to follow best practices. To help new teams gain these capabilities, or existing teams to raise their bar, we enable access to a virtual community of principal engineers who can review their designs and help them understand what AWS best practices are. The principal engineering community works to make best practices visible and accessible. One way they do this, for example, is through lunchtime talks that focus on applying best practices to real examples. These talks are recorded and can be used as part of onboarding materials for new team members. I'm thinking in the back of my head, how does this apply to smaller businesses? If a small business is using AWS, they're not going to have a whole team of engineers and a principal engineer giving lunchtime AWS talks. I guess in those cases, often they might hire a AWS consulting partner, and they provide that review or even implementation. And then the role of those lunchtime talks is those AWS partners getting training by watching reInvent talks and things like that. Anyway, that's what's going on in the back of my head now. AWS best practices emerge from our experience running thousands of systems at internet scale. We prefer to use data to define best practice, but we also use subject matter experts, like principal engineers, to set them. As principal engineers see new best practices emerge, they work as a community to ensure that teams follow them. In time, these best practices are formalized into our internal review processes, as well as into mechanisms that enforce compliance. WellArchitected is the customer-facing implementation of our internal review process, where we have codified our norms. Good intentions never work. You need good mechanisms to make anything happen, says Jeff Bezos. This means replacing human best efforts with mechanisms, often automated, that check for compliance with rules or process. Working backward is a fundamental part of our innovation process. We start with the customer and what they want and let that define and guide our efforts. Okay, so that was giving some background about the AWS WellArchitected Framework and how it came out of Amazon's internal process for doing things well, namely having review processes that are very systematized and sometimes even automated. Okay, so WellArchitected is the customer-facing implementation of our internal review process, where we have codified our principal engineering thinking across field roles like solutions architecture and internal engineering teams. WellArchitected is a scalable mechanism that lets you take advantage of these learnings. By following the approach of a principal engineering community with distributed ownership of architecture, we believe that a well-architected enterprise architecture can emerge that is driven by customer need. Technology leaders, such as CTOs or development managers, carrying out well-architected reviews across all your workloads will allow you to better understand the risks in your technology portfolio. Using this approach, you can identify themes across teams that your organization could address by mechanisms, trainings, or lunchtime talks, where your principal engineers can share their thinking on specific areas with multiple teams. So I guess it's kind of a way of taking an inventory of your architecture and your strengths and weaknesses in that architecture. And that's one thing that's nice with the WellArchitected tool as well. Gives you that visual of where you're doing well and where you're not doing well. It's kind of like that saying that you can't improve it unless you're measuring it, like with diet, tracking the food you eat, or with sleep, tracking how you're sleeping. Here, you might not know that you have this security risk until you go through a checklist, because humans don't think in checklists. They actually need the checklist. Next section, general design principles. The WellArchitected Framework identifies a set of general design principles to facilitate good design in the cloud. First one, stop guessing your capacity needs. Eliminate guessing about your infrastructure capacity needs. When you make a capacity decision before you deploy a system, you might end up sitting on expensive idle resources or dealing with the performance implications of limited capacity. With cloud computing, these problems can go away. You can use as much or as little capacity as you need and scale up and down automatically. So I guess that's just highlighting a general perk to the cloud, because with all of the services, it's pretty much on demand unless you're using reserved EC2 instances. And that's only once you've figured out what your on-demand usage is that you would typically use those reserved instances. So, okay. Next general design principle, test systems at production scale. In the cloud, you can create a production scale test environment on demand, complete your testing, and then decommission the resources. Because you only pay for the test environment when it's running, you can simulate your live environment for a fraction of the cost of testing on premises. So that's another just benefit to doing things in the cloud that they're telling us here. because when you do a test with just test scale, instead of going full out and launching all the resources and scale you would for production, you're not going to get a full and accurate impression of what production will be like. And since the cloud lets you provision 1,000 computers all of a sudden, and then within seconds destroy them for all intents and purposes from your perspective, you might as well get that full view and test it at scale. Another general design principle: automate to make architectural experimentation easier. I'm guessing that ties into the previous one, because if you can automate the deployment of those services using Terraform or CloudFormation, then you just gotta click Terraform apply or CFN deploy to launch all of those resources and then be able to destroy them again. So this is what they say about automating to make architectural experimentation easier. Automation allows you to create and replicate your systems at low cost and avoid the expense of manual effort. You can track changes to your automation, audit the impact, and revert to previous parameters when necessary. Next general design principle: allow for evolutionary architectures. That's interesting. I just watched Dr. Werner's 2019 reInvent keynote. He's the CTO of AWS, and he talked about how S3 from the beginning was built to allow for evolutionary architecture. And that's why they started off with, I don't know, it was like a dozen microservices, and now they have, I forget, maybe like over 300 microservices. And that's because of how they architected it from the beginning to allow for that evolution. So I'm going to highlight that and add a note about S3 and Dr. I think his name is Werner Vogels. Okay, I'm gonna just look that up really quick. Werner Vogels. Yes, indeed. That's with a V. I say Vogels because I think he's from Denmark, and I'm from Germany, and I think it's a similar pronunciation. Oh, Netherlands. Oops. Okay. So, yeah, allow for evolutionary architectures. In a traditional environment, architectural decisions are often implemented as static, one-time events with a few major versions of a system during its lifetime. As a business and its context continue to change, these initial decisions might hinder the system's ability to deliver changing business requirements. In the cloud, the capability to automate and test on demand lowers the risk of impact from design changes. This allows systems to evolve over time so that businesses can take advantage of innovations as a standard practice. So I think that's a really important one for leaders in the tech space or leaders who have been involved in tech decisions to be aware of when they're moving into cloud, that I don't want to say they don't have to put as much weight on making architectural design changes, but they can expect and look for opportunities to make changes more frequently than they did in the past, because the resources available for making those changes are constantly being added by AWS, and also the customer's need is constantly changing, which it was in the past, but now with the on-demand nature of the cloud, businesses can actually try to move their technology at the pace of their business. So the next design principle, general design principle they have here, drive architectures using data. In the cloud, you can collect data on how your architectural choices affect the behavior of your workload. This lets you make fact-based decisions on how to improve your workload. Your cloud infrastructure is code, so you can use that data to inform your architecture choices and improvements over time. Right, so I guess there are a lot of ways to collect data on your workload. One is to use the WellArchitected tool and answer those questions so you can see over time how your answers change. And of course, then there's more pure number-based metrics that you can use, such as CloudWatch metrics. Like you can maybe see your latency go down as you maybe switch for instance types, or as you use, what are they, like placement groups, or you can see your what other metrics might you want to see over time? Well, I guess that's a question to keep a look at for as we read this paper. I'm going to make a note. I'm curious what they say are metrics to track over time. So another one is improve. I just thought of another one. There are kind of default config rules that you can apply, and when you first turn those on, they might be out of compliance, and then as you improve your environment, they'll eventually be in compliance, and you can see that progress over time. Another one is Trusted Advisor. I don't think that one lets you see the progress over time, but it's collecting data for you over your workload. Another general design principle, improve through game days. This is a cool one. Test how your architecture and processes perform by regularly scheduling game days to simulate events in production. This will help you understand where improvements can be made and can help develop organizational experience in dealing with events. Okay, so now we're getting into the main section of the white paper, the 5 pillars of the framework. Creating a software system is a lot like constructing a building. If the foundation is not solid, structural problems can undermine the integrity and function of the building. When architecting technology solutions, if you neglect the 5 pillars of operational excellence, security, reliability, performance efficiency, and cost optimization, it can become challenging to build a system that delivers on your expectations and requirements. Incorporating these pillars into your architecture will help you produce stable and efficient systems. This will allow you to focus on the other aspects of design, such as functional requirements. So I guess it's saying that if you have a systematic way of covering the essentials, those 5 pillars, it's easier to then focus on what makes your app unique the functional requirements. Okay, so here's the first pillar, operational excellence. The operational excellence pillar includes the ability to run and monitor systems to develop business value and to continually improve supporting processes and procedures. The operational excellence pillar provides an overview of design principles, best practices, and questions. You can find prescriptive guidance on implementation in the operational excellence pillar white paper. So here they're pointing out that every pillar that's reviewed in this white paper has its own white paper. So design principles for the operational excellence pillar. These are the 6 design principles for operational excellence in the cloud. First, perform operations as code. Okay, so what they put front and center for having operational excellence in the cloud is using infrastructure as code. Gotta use CloudFormation or Terraform. Those are the 2 main ones, and then there are frameworks on top of that, sometimes like the serverless framework and SAM. But you gotta use infrastructure as code because it's so hard to keep track of changes if you don't have it as templates that you can put in your version control system. I guess I'll talk about that here. So in the cloud, you can apply the same engineering discipline that you use for application code to your entire environment. You can define your entire workload, applications, and infrastructure as code and update it with code. You can implement your operations procedures as code and automate their execution by triggering them in response to events. By performing operations as code, you limit human error and enable consistent responses to events. Pretty straightforward. So the next one is annotate documentation. In an on-premises environment, documentation is created by hand, used by people, and hard to keep in sync with the pace of change. In the cloud, you can automate the creation of annotated documentation after every build, or automatically annotate handcrafted documentation. Annotated documentation can be used by people and systems. Use annotations as an input to your operations code. Okay, that's actually a pretty interesting one. I'm kind of curious what they mean by that. So they're saying that the infrastructure as code can generate annotated documentation, and that can be used by people and systems. Well, I know that you can have outputs for your CloudFormation stacks, which can be helpful to read for the humans reviewing that deployment, and can also be used as inputs for other operations. That sounds a lot like this, but I wouldn't call those outputs documentation, but I suppose you could output it and then use that output as string interpolation in some documentation. But I'm curious if they say more about that later or in the operational excellence white paper. So I'm going to add a note. More about this in the Ops Excellence white paper? Question mark? Okay. Cool. Make frequent, small, reversible changes. Design workloads to allow components to be updated regularly. Make changes in small increments that can be reversed if they fail, without affecting customers when possible. That sounds like using an agile methodology for infrastructure changes, not just for your software, because I guess that way you get in the habit and you have systems in place for rollbacks so that you can make these changes safely. Next general design principle for operational excellency is refine operations procedures frequently. So that sounds similar to the above one, especially since they're saying to make operational procedures in code when possible. But let's see what they say. As you use operations procedures, look for opportunities to improve them. As you evolve your workload, evolve your procedures appropriately. Set up regular game days to review and validate that all procedures are effective and that teams are familiar with them. Okay, so I guess you can't fully make game day code that's triggered based on the event, because I think, as far as I know, game days involve humans too, which explains why they put that as a separate design principle. Wow, okay. So this is a good data point. After 11% of this 100-page white paper, I'm getting a bit of a raspy throat. I'm going to go a little further and see how that goes. Anticipate failure. Perform pre-mortem exercises to identify potential sources of failure so that they can be removed or mitigated. Test your failure scenarios and validate your understanding of their impact. Test your response procedures to ensure that they are effective and that teams are familiar with their execution. Set up regular game days to test workloads and team responses to simulated events. Okay, so think ahead of what failures can occur, plan for the worst, and test how you would act if the worst were to happen. Basically, make fire drills for the cloud. Okay, last general design principle for operational excellency: learn from all operational failures. Drive improvement through lessons learned from all operational events and failures. Share what is learned across teams and through the entire organization. Okay, so learn from those fire drills and learn from real failures, and document it and publicize it inside of your organization. Next section on operational excellency, definition. There are 3 best practice areas for operational excellence in the cloud: prepare, operate, evolve. Operations teams need to understand their business and customer needs so they can effectively and efficiently support business outcomes. Operations creates and uses procedures to respond to operational events and validates their effectiveness to support business needs. Operations collects metrics that are used to measure the achievement of desired business outcomes. Everything continues to change: your business context, business priorities, customer needs, etc. It's important to design operations to support evolution over time in response to change and to incorporate lessons learned through their performance. So how do you design operations to support evolution over time? I guess one thing would be to have a way of tracking operations over a function of time, kind of like the way the WellArchitected tool lets you do. You can see the changes over time, or the way config lets you track your operational settings over time. And if you have your own internal processes, it might be good to track those as a function of time as well. Best practices. Prepare. Effective preparation is required to drive operational excellence. Business success is enabled by sharing goals and understanding across the business, development, and operations. Common standards simplify workload design and management, enabling operational success. Design workloads with mechanisms to monitor and gain insight into application, platform, and infrastructure components, as well as customer experience and behavior. Okay, so the way you monitor an application and infrastructure and platform should go into your design of it. So from the very beginning of designing a solution, you should already be thinking of how you're going to monitor that solution. So I guess monitoring is an important part of operational excellency. Create mechanisms to validate that workloads or changes are ready to be moved into production and supported by operations. Operational readiness is validated through checklists to ensure a workload meets defined standards and that required procedures are adequately captured in runbooks and playbooks. Validate that there are sufficient trained personnel to effectively support the workload. I think that's a really important point. There are certain things that you would want any production workload to have, such as a certain degree of logging, a certain degree of metrics captured, and certain level of security that you would just want to have for any production deployment. So since that's the same for all of them, it's good to have checklists for those so that you have a mechanism for moving workloads from development to production. So I'm going to highlight that one. Because I think that one can be sometimes overlooked because we get so engrossed in one project, we forget to see the similarities between projects, and then we just end up making the same checklists for different projects. They're going to vary, of course, but it would be interesting to find the common points that are for each one and draw those out. I mean, that's not necessarily what they're saying here, but that's what I think of here. Validate that there are sufficient trained personnel to effectively support the workload. Yeah, that's important too, because you wouldn't want to have like a self-hosted Kubernetes cluster that you're developing and then just hand it off to production without like 2 full-time trained Kubernetes staff or things like that, because if you don't have that staff to support it, you may want to use a fully managed Kubernetes service like Amazon Kubernetes service, or you might want to just use Lambda, which takes even less support, basically none, one might say. Close to none. Practice responses in supported environments through failure injection and game day events. AWS enables operations as code in the cloud and the ability to safely experiment, develop operations procedures, and practice failure. Using AWS CloudFormation enables you to have consistent, templated sandbox development, test, and production environments with increasing levels of operations control. AWS enables visibility into your workloads at all layers through various log collection and monitoring features. Data on use of resources, application programming interfaces, and networking flow logs can be collected using Amazon CloudWatch, AWS CloudTrail, and VPC flow logs. You can use the collected plugin or the CloudWatch logs agent to aggregate information about the operating system into CloudWatch. The following questions focus on these considerations for operational excellence. For a list of operational excellence questions, answers, and best practices, see the appendix. Oh, cool. So in the appendix, they include a bunch of questions, which are probably also in the WellArchitected tool. Operational Excellence 1. How do you determine what your priorities are? That's a really interesting question because it kind of reminds me right now of when I hear news about the pandemic that's going on. How do you decide when the lockdown ends? How are you making those decisions? Because what that kind of a question does is it makes you move from grabbing numbers out of the air and making decisions based on gut feeling, and it forces you to make decisions based on data or actual experience. So their explanation of that question is, everyone needs to understand their part in enabling business success, have shared goals in order to set priorities for resources. This will maximize the benefits of your efforts. Okay, so I guess they're saying one way to determine what the priorities are is to have overarching goals where that guide what your other priorities are. Question 2. How do you design your workload so that you can understand its state? How do you design your workload so that you can understand its state? Wow. I guess that is similar to that thing we were just talking about designing your monitoring solution from the start. Like, as you're designing your solution, design the way you're going to monitor that from the beginning so that you can understand the state of the workload. So how do you design your workload so that you can understand its state? Design your workload so that it provides the information necessary for you to understand its internal state. For example, metrics, logs, and traces across all components. This enables you to provide effective responses when appropriate. So when you're designing your architecture diagram, you'll want to already be thinking of putting a CloudWatch logs agent in CloudWatch, or tracing your serverless architecture with SNS and Lambda using X-Ray. Okay, operational excellence question 3. How do you reduce defects, ease remediation, and improve flow into production? Adopt approaches that improve. Okay, let me go back to that question. How do you reduce defects, ease remediation, and improve flow into production? I think that's kind of what people like talking a lot about, like developer velocity, or innovation speed, and how do you increase that speed of innovation? What are you doing to make the speed of your innovation greater? I think that's a great question, because often we can get engrossed in the nitty-gritty of a project or of a company's day-to-day, and we can forget to step back and ask, what are we doing in terms of processes to make us develop solutions faster? So the explanation here of that question: adopt approaches that improve flow of changes into production, that enable refactoring, fast feedback on quality, and bug fixing. These accelerate beneficial changes entering production, limit issues deployed, and enable rapid identification and remediation of issues introduced through deployment activities. That reminds me, I heard Facebook has at all times something like 100,000 versions of Facebook running at any given time, because developers are constantly testing new features, and they're only testing it on a small fraction of the total users, and that's one way they speed up innovation, is by enabling fast feedback on quality. They don't have to wait for one feature to be tested to test another feature. No, they can just test hundreds of new features at the same time. Operational excellence 4. How do you mitigate deployment risks? Okay, yeah, so there are risks to deployments, and how do you do your best to mitigate those risks? Adopt approaches that provide fast feedback on quality and enable rapid recovery from changes that do not have desired outcomes. Using these practices mitigates the impact of issues introduced through the deployment of changes. So, adopt approaches that provide fast feedback on quality and enable rapid recovery from changes. Okay, so basically rollback strategies, in other words, and mechanisms to know when you should be rolling back. So ideally having some automated ways, or at least maybe reducing the impact of bad deployments by doing like a canary deployment, where, like with that Facebook example, you're only deploying it to a small fraction of your users so that you get fast feedback but with less risk, and then you can roll back without your whole user base seeing those bad changes. Operational excellence question 5. How do you know that you are ready to support a workload? So I guess that's a good question to ask as you're moving into production. Like, have you set up the monitoring? Have you set up the ability to make changes? So let's see what they say. Evaluate the operational readiness of your workload, processes and procedures, and personnel to understand the operational risks related to your workload. If you have 10 really highly trained people supporting your workload who understand the architecture, that reduces your risk compared to having 2 people who can support that. So I think it's cool that they include understanding the personnel in here. So we've reached the hour mark of reading this. We've gotten 14% through the WellArchitected Framework Whitepaper, and I will stop it for here for today. And I'll just read the last two paragraphs since we're at the end of this questions. Here we go. Implement the minimum number of architecture standards for your workloads. Balance the cost to implement a standard against the benefit to the workload and the burden upon operations. Reduce the number of supported standards to reduce the chance that lower than acceptable standards will be applied by error. Operations personnel are often constrained resources. So that's interesting. It's saying, take everything with a grain of salt. You only have so much staff for operations oftentimes, so make sure you really carefully choose which standards you're choosing, and reduce the number of supported standards. I guess it's not said directly here, but this makes me think like if you have too many rules, you might not be following them all. Choose some really good rules and stick by those. Invest in implementing operations activities as code to maximize the productivity of operations personnel, minimize error rates, and enable automated responses. Yeah, so that's a good point. The more you can automate operations, the more effective the people time is, because they can work on the important stuff. Adopt deployment practices that take advantage of the elasticity of the cloud to facilitate pre-deployment of systems for faster implementations. Okay, so tomorrow I plan on continuing with the operate section of operational excellency section of the AWS WellArchitected Framework, and I'll continue commenting as I go to help me understand what I'm reading, and maybe if you've listened this long, it's helped you a little bit too. Okay, if you have any requests for other white papers for me to read next after I read this one and the 5 other ones related to it, let me know in the comments. Okay. Bye.